Hello and welcome back. Thank you for joining us. Today we're going to be finding the midpoint of a line segment, and then we're also going to focus on distances on a number line. Okay, so we'll go ahead and get started here with the midpoint. So the midpoint of a line segment is the point halfway between each of the endpoints. You can use the coordinates of the endpoints of a line segment to find the coordinates of the midpoint of a line segment. The formula to find the midpoint between the two coordinates is big M, so the big M stands for midpoint, equals x sub 1 plus x sub 2 divided by 2, and then so that'll be the x coordinate, and then the y coordinate will be y sub 1 plus y sub 2 all over 2. All right. Find the midpoint of the line segment having endpoints at 4, 3, and negative 3, negative 1. So in a minute we're going to use this formula, but first I want to think about it graphically so we could actually derive the formula. So let's go ahead and plot this point 4, 3. So we have 1, 2, 3, 4, 1, 2, 3. We'll plot that, and then negative 3, 1. 1, 2, 3, negative 3, negative 1. So we'll go ahead and plot that. And why don't we go ahead and take our ruler and connect these 2 points. And then we'll think about what they're asking us for the midpoint. Okay. So now they're asking us for the midpoint between this. Now let's think about it. Like if we go from here and count over how far and find halfway there, and then if we see how tall is it from here up to here and find the halfway there, that should give us the midpoint of this segment. Let's try it that way and see what happens. Okay, so we started here, and we're going to count over and see how many we count to get over to here. All right, so starting here, we count over 1, 2, 3, 4, 5, 6, 7. So half of this distance, 7. So this total distance from here to here is 7, and then half of that is 7 divided by half. That's 3.5. So my idea is maybe if we count it over 1, 2, 3.5, it's going to land in here. But let's try the that's the horizontal. Let's try the vertical distance and see what happens. So we started here, and we need to go all the way up to here. So let's see how many that is. So if we start here, we go up 1, 2, 3, 4 units. From here to here is 4 units. And then we know half of 4 is 2. So I'm thinking if we started here and we went up to 1, 2, then that's where it's going to be. Okay. So let's see 3.5 and 2. Let's see. 1, 2, 3.5, and that puts us at up to 1, 2. 1, 2. So just graphically, we're believing that the midpoint is going to be, okay, so if we go over 3.5 from here, 1, 2, 3.5, on our x-axis that would be 0.5 or 1/2. Why don't we just call it 1/2? And then on the y-axis, let's see, we started here and we went up 1, 2, 2. So that would be y-axis, that would be at 1. Let's try it with our formula and see what happens. Okay, so we're going to use the formula now. M equals x sub 1 plus x sub 2 all over 2, and y sub 1 plus y sub 2 all over 2. So we have x sub 1 here, y sub 1, x sub 2, y sub 2. All right. So let's plug it in. X sub 1 is 4 plus negative 3 is divided by 2. And then we had y sub 1 as 3 plus y sub 2 as negative 1. And that's over 2. All right. So we have 4 plus minus 3 plus a negative 3. So 4 minus 3. 4 minus 3. That'll be 1. And that's over 2, 1/2. Let's see what we come up here to. 3 plus a negative 1. So that's 3 minus 1. So that's 2. So now we have 2 over 2. And of course this is going to reduce. So now we know the midpoint is at 1/2, 1. 1/2, 1. Well, that's what we figured out when we did our illustration here. 1/2, 1. Okay? All right. So on these examples down here, what we're going to do is we'll just go ahead and use the formula itself. Referring back to the formula, so why don't we label x sub 1, y sub 1, x sub 2, y sub 2. So now we have midpoint equals x sub 1 is 8 plus x sub 2 is 6, and that's all over 2. And y sub 1 is going to be 9 plus y sub 2 is 11. It's over 2. So now we have 8 plus 6. So that's 14 over 2. And 9 and 11. So that's going to be 20 over 2. Both of these are going to reduce. Here we have 7 and 10. So our midpoint is going to be at the ordered pair of 7, 10. Okay. Now let's go on to this one. Maybe we'll label again. X sub 1, y sub 1, x sub 2, y sub 2. So now we have the midpoint is at x sub 1, negative 4, plus x sub 2 is 10. That's divided by 2. And then we have y sub 1 is 6, plus y sub 2 is negative 2. That's over 2. All right. So here we have negative 4 plus 10, or 10 minus 4. So that's going to be 6 over 2. And here we have 6 plus negative 2, or 6 minus 2. So that's going to be 4 over 2. So here we have 3, 2 as our ordered pair. So the midpoint for this one is going to be at the ordered pair 3, 2. All right. Okay, let's move on to the next little chunk here. Distance between points on a number line. Okay. So, let's see what we have. A number line is a horizontal line with integers evenly spaced on the line and an arrow at each end. Negative integers are on the left side of 0 on the line, while positive integers are on the right side of 0. The arrows at the ends of the line are meant to indicate that the line goes on forever in each direction. Even though only integers are shown on a number line, the number line represents all real numbers. As one goes from left to right on a number line, the numbers will always become greater. That is, if A is less than B, then A will be to the left of B on the number line, and B will be to the right of A. The distance between 2 points on a number line can be obtained by finding the absolute value of the difference of the numbers representing those points. In other words, the distance between A and B on a number line is A minus B, the absolute value of that. The absolute value of A minus B. Okay? So we'll take a look here. They've given us a number line, and they're telling us that on the number line shown below, find the lengths of the segments, and then they gave us these segments. So D's at -6, A's at -2, C is at 4, and B's at 7. Okay, and then we've been given a couple steps we will follow. Since the distance between A and B on a number line is the absolute value of their difference, the distance between D, -6, and A, which is -2, is -6 minus -2, which is -6 plus 2. And then so -6 plus 2, the absolute value. So that's going to be the absolute value of -4, and the absolute value is 4. Okay. Therefore, the length of segment DA is 4. Okay, now we'll do it this way, but another way you can think about it is you could just go from D and count 1, 2, 3, 4. It's 4, and confirm your work. Okay, they want us to find DC, so here we go. So it's the absolute value between -6 and -4. -4. Okay, so the absolute value of that. So that's the absolute value of -10. So the distance is actually 10. Distance is 10. And we can count from here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And we got it. Okay? Now we'll do dB the same way. It's the absolute value of D minus B is 7. So that's the absolute value of, so that's going to be 13, -13. The absolute value of -13 is 13. Let's check. So we start here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, 13. Yes, we're good. Okay, AC. Let's try it now. The absolute value of -2 minus C is 4. So here we go. Absolute value of 4, 6, -6 equals 6. Okay. AC, 6. 1, 2, 3, 4, 5, 6. Good. All right. AB. So A is -2. Absolute value of -2 minus B is 7. So here we go, 7, -9, which the absolute value of that is 9. Okay, 9. So let's take a look at the next one, CB. C is 4. 4 minus B is 7 equals -3. The absolute value of -3 is 3. Okay. There we go. And we'll count 1, 2, 3. Got it. Okay. So that's absolute value. The distances between points. And of course we could find it the other way too if they gave us the distance between CA. Let's try it. Well, it'll come up to the same one as this, but let's say they said the segment CA. Let's say that was. So we would start with C is 4 minus A, which is -2. -2. -2. The absolute value of that. So 4 minus negative, so it's plus. 4 plus 2. The absolute value of 4 plus 2 is 6. Absolute value of 6 is 6. Same thing we came up with. 1, 2, 3, 4, 5, 6 distance. Okay. Now let's look at this example here. Points A, B, C, and D are located on a number line. Okay, so we'll draw our number line. Point D is to the left of C. Okay, so D is to the left of C. So C is somewhere out here. Point B is to the left of A. So B and A are going to be arranged like this. Point A is to the left of point C. Okay, so if C's over here somewhere, A's to the left of that. Why don't we put C over here? C's over here, and then that would make A here and B here. Okay, now, if it can be determined, state whether the lengths of segments B, and they give us all these, 1, 2, 3, 4, 5. They give us 5. Why don't we list them out? DB, segment DB, segment DA, DC, segment DC, BC segment, and AC. Okay. State whether these segments, blah, 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 are greater than, less than, or equal to the length of the line segment BA. So our focus is right here on this, BA. And we don't know the distances. It could be 5 units, a half a unit. We don't know the distances between any of these. But let's take a look at the first one. We're comparing it to BA. Okay. Now they want us to say DB. Well, this in relation to this, we don't know. We can't tell. We don't know the distances, any units in between. So we're going to say for this one, can not be determined. We're just using their verbiage, okay? At DA, let's look at DA. So this length from here to here, well, it includes this length, so it must be greater than. DA is greater than BA. Greater than BA for sure, okay? All right, let's look at the next one. Next one they gave us was DC. DC, well, that's the entire thing. So it's going to encompass this. So it must be greater than segment BA. Okay. Then the next they gave us is BC. BC. Well, once again, it encompasses BA. So this is going to have to be greater than segment BA. All right, and then they said segment AC. So this chunk right here, what's the relationship? Well, we don't know because all these distances we don't know the distances, any of them, between these because they didn't give us any points. So we're going to say the same thing we said for this one. Can not be determined. Okay, so here you have it. We have studied the midpoint and the midpoint formula. We've studied distances between points on a number line. And so that concludes our lesson for today. Thank you so much for joining us, and we will look forward to seeing you on the next segment.